All right, this is part 3 of Unit 10, Electron Bonding and Shapes, and this is about our shapes specifically. All right, so VSEPR is about valence shell electron pair repulsion theory. And this really is about how the valence electrons on the central atom are going to repel each other or try to get as far apart from each other. And that is because like charges are going to repel and opposites attract. So that's why the electrons will go around the nucleus, is because the electrons are negative and the nucleus is positive. But the electrons want to push away from each other, okay, a lot like magnets. All right. Now, regions of electron density are where pairs of electrons can be found, and they can be used to determine the shape of the molecule. So that's really what the VSEPR theory is primarily for, is to determine the shape of a molecule. So, for example, CO2, we have carbon double bonded with oxygen on either side. And we have two regions of electron density because the electron density is around the central atom, how many bonds are taking place and or how many electron pairs there are. And so there's two regions where there's bonds taking place, okay? And so because there are two regions, we call this linear because they want to be as far apart as possible. All right, so your first shape to know is linear, and it has two regions. Another thought is on the central atom, there's no lone pairs at all when we have linear, okay? So a way to think about linear is there's no lone pairs, and it's either bonded to one other atom or two atoms. And that's it. So the central has either only one bond or two, and it has no lone pairs on it. So there's no lone electron sets of just those two dots on this central atom. Okay, then we have CH4. CH4, remember, has a picture of carbon in the middle and hydrogens on either side. So we find 4 electron pairs around the central atom. So 1, 2, 3, 4. Another way of thinking about this is that there's 4 elements or 4 bonded elements around the central atom. And so there's 1 bond, there's 2 bonds, there's 3 bonds, there's 4 bonds. So we would expect these to be like 90 degrees around each other, like it looks when it's flat on the paper. But in real life, when it's in 3D, there's actually 4 regions, and they're 109.5 degrees apart. You don't specifically have to know the 109.5 degrees, but it is good just to know how it looks and how it's represented. So we call this shape a tetrahedral. So the thing to realize about this is on the central atom, there's no lone pairs, and there's 4 elements bonded to the central atom. Okay, so if there's 4 elements bonded to the central atom and no lone pairs, then it'll be the shape of a tetrahedral. All right, the next one is NH3. So when we drew the diagram, it looked like this with nitrogen in the middle. It had 3 bonded pairs and 1 lone pair. Okay, so there are still 4 regions of electron density. 1 is the lone pair, and then the other 3 are the bonds. Okay, so one of those is a lone pair, though. Okay, so that's different than what we just had. So that creates what we call a pyramidal shape. So when you're trying to figure out the shape, if you have 3 elements bonded to the central atom and a lone pair, then that would make it a pyramidal. Okay, when we had 4 elements, remember, bonded to the central atom and no lone pairs, that was tetrahedral. Okay. Then we have H2O. H2O looks like this when we drew it as a Lewis dot structure. The thing to realize is there are still 4 regions of electron density. We have 2 lone pairs and 2 bonds. Okay, but again, 2 of them are lone pairs and 2 of them are bonds. So when we look at this, the structure is going to be referred to as bent because those lone pairs are going to want to get as far away as possible from the bonds. So it will cause this to create this 109.5 degree angle between these atoms right here. So a way to kind of see if an atom is, or an element a compound is this, you will say if it's got two elements bonded to the central atom and two lone pairs, then it's going to be bent. All right. Remember when we talked about linear, it was just two elements bonded to the central atom and no lone pairs. So you have to pay attention to how many lone pairs and how many bonded elements are there to the central atom. The central atom is the one in the middle, remember. And then our last one, and I really would have preferred to use a different compound versus an ion. We could have also used something like COCl2. That would have been another one that would have given us this shape, okay? Because instead of the oxygens right here and here, we could have had the Cl's. So we could have had C, and then we could have a double bond O dot 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 dot, and then we'd have oxygen chlorine over here dot 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 dot, and chlorine here. And the reason I say this is because we're not going to give you ions. We're not going to test you on ions on the test. So I prefer you look at this picture right here instead of this example. But there are three regions of electron density when we talk about that, and the three regions would be here and here and here. So those would be our three regions of electron density, would be where those bonds are taking place. Notice there's no single lone pairs on the central atom, and this is going to be referred to as a trigonal planar, okay, or trigonal planar. You can say it either way. But this is going to be a little bit different than the tetrahedral in the fact that we only have three elements bonded to the central atom, but there's no lone pairs. Whereas on the pyramidal, we had three bonded and one lone pair. So you just have to pay attention to how many elements are bonded to your central atom and how many lone pairs there are. So let's practice. We have H2S. So we have two elements bonded to the central atom and two lone pairs. So because there's four regions with two lone pairs, and that would be bent. Then if we have SO2, okay, we have a double bond and a single bond, and we have three areas of electron density. So we have two elements and a single bond, a single lone pair. So that would be going to be bent as well. All right. We won't do one like that on the test, by the way. CCl4. So we have four elements bonded to the central atom, no lone pairs. So that would make it going to be tetrahedral when we look at it in 3D. Okay. Then if we have BF3, okay, we have three elements bonded to the central atom, and we have no lone pairs, so that would be trigonal planar. Then we have NF3, so we have, that is a picture of NH3, so I probably ought to fix that. That's NH3 instead. If I had made this, actually, let me show this as, if I say this is NF3, so that would be N, and then F3 would be F, and then we'd have 1, 2, 3, 4, 5, 6, F, 1, 2, 3, 4, 5, 6, and F, 1, 2, 3, 4, 5, 6, and then we'd have to put two more right here. So it's very similar, except instead of hydrogens, I'd have fluorines that had, so it has one lone pair and three bonded, so that would make it actually pyramidal. All right. So that finishes the Unit 10 notes, Part 1, 2, and 3. Again, you have practice on your classwork and homework, and if you have any questions, please contact me. Have a good one.